Hello, I welcome you all to this lecture session of second law of thermodynamics. I am Shikha Bhoya, Assistant Professor, Department of Mechanical Engineering, Tejpur University. This is the lecture outline. First, I would like to give the idea that why do we need to understand the second law of thermodynamics. Secondly, the statements of second law of thermodynamics that is given by two statements, Kelvin-Planck statement and Clausius statement. Thirdly, I would elaborate the concept of heat engine, heat pump, refrigerator and perpetual motion machine of the second type. And lastly, the Carnot engine. Now, why do we need to understand the second law of thermodynamics? As we all know that first law of thermodynamics gives the idea of conservation of energy. However, it doesn't give the idea of feasibility of working of any process. But the second law of thermodynamics gives you the idea whether the process is feasible in a particular direction or not. That is why it is also known as the directional law. Here, two important terms is needed to be understood. First is the work transfer and second is the heat transfer. Work transfer is known as high-grade energy and is an organized form of energy. Heat energy is a low-grade energy and it is disorganized form of energy. It says that complete conversion of low-grade energy into high-grade energy in a cycle is impossible. Now, the statement of second law of thermodynamics is given by two statements known as Kelvin-Planck statement and Clausius statement. The Kelvin-Planck statement states that it is impossible to develop a device operating on a cycle producing work by exchanging heat with a single reservoir. If this happens, then this device is known as perpetual motion machine of the second type, which is 100% efficient and is impossible to create. This is the schematic of the perpetual machine of the second type, where Q amount of heat is extracted from the heat source and is completely converted to the work energy, which is not possible. Secondly, Clausius statement states that it is impossible to transfer heat from low temperature to high temperature without any external input. Now, what is heat engine? Heat engine is a device which converts part of heat into work and rejects remaining to sink or surrounding. It is a work producing device. Concept of heat engine is given by Kelvin-Planck statement, which says that complete conversion is not possible, but partial conversion is possible with the help of the interaction between two thermal reservoirs. In this diagram, it is seen that QH amount of heat is extracted from high temperature thermal reservoir, which is giving you a partial conversion with an work output W, and rest is rejected to a sink of low temperature reservoir and the amount is QC. Now, the efficiency is given by the ratio of the amount of output obtained by the input given to the system. In our case, it is heat engine. So, efficiency finally is given by the ratio of W, which is the output in this case, divided by Q. In this case, it is QH. So, W is given by the difference between the amount of QH and QC. And finally, we come to the expression of efficiency in this form, that is QH minus QC divided by QH. This is followed by 1 minus QC by QH. Now, what is refrigerator? A refrigerator is a device which maintains lower temperature corresponding to surroundings, and heat pump is a device which maintains higher temperature compared to surrounding. Unlike heat engine, which is a work producing device, refrigerator and heat pump are work consuming device. In this diagram, we have QL and QH, which are QL heat absorbed from low temperature reservoir and QH is the heat rejected to high temperature thermal reservoir when work is done on it. The performance of refrigerator and heat pump is analyzed with the help of a term called COP. It is the abbreviation of coefficient of performance. Coefficient of performance COP of refrigerator is given by the ratio of QL by W, where QL is the desired effect from the refrigerator. So the COP of refrigerator is QL by W, and W can be replaced by the difference of QH minus QL. And COP of heat pump is given by QH by W, where QH is the desired effect in case of heat pump. The relation between two COPs is given by this blocked expression. Now, what is Carnot cycle? According to thermodynamics second law, a heat engine can never be 100% efficient. Then, what is the most efficient cycle we can have? This is the Carnot cycle, and which is reversible in its nature. The cycle is said to be reversible when each process in a cycle is a reversible process. This is the TS diagram, that is temperature entropy diagram. It is consisting of two isothermal processes and two adiabatic processes, and is shown clearly in this TS diagram. 1 to 2 is an isothermal heat addition, 2 to 3 is an adiabatic expansion, 3 to 4 is an isothermal heat rejection, and 4 to 1 is an adiabatic compression process. Now, Carnot engine consists of two reversible adiabatic and two reversible isothermal processes. However, it is not practically possible and is a hypothetical engine, because to realize isothermal condition, the process must be carried out in a very slow manner, and to realize adiabatic conditions, the process must be carried out in a very fast manner, which is not possible to do in a simultaneous process, and hence these two combinations in a cycle is not feasible. Therefore, Carnot cycle is a theoretical cycle and is simply used for comparing other actual cycle. I would like to end this lecture with conclusion that in the present lecture, the second law of thermodynamics is discussed. The law is significant to explain the feasibility and direction of occurrence of any thermal process. The application of second law, that is refrigerator, heat pump, perpetual motion machine of second type, are discussed, as well as its idle processes. This is the reference which I have referred for preparing this content. This is a book called Thermodynamics and Engineering Approach by Sengels and Boles. Thank you.